Episode 1: How to Think Like a Mathematician. Hey guys, welcome to my channel Math for Teens. In today's video, I'm going to try and learn to think like a mathematician. This is because I've been doing competitions since 10th grade, so like 2 years now, math competitions, and it's never really ended well for me. So I have many competitions coming up in the next few weeks, next few months, and it is my personal goal to succeed in them, because why not? So yeah, this video is all about learning to think like a mathematician in the context of math competitions. So I'm going to be using the 2025 Euclid Contest, which is a competition made for 12th graders. There's 10 questions, and I'll be doing 5 of them in this video. Next video, we'll do the other 5. Anyways, so let's get started. Question 1. If 4 times x minus 2 is equal to 2 times x minus 4, what is the value of x? So if these two expressions need to be the same, well, automatically you can just look at it, and if you can see that if x is just 0, both sides are going to be minus 8. So the answer to this one is just x is 0. Yeah. So that one's pretty evident, I would say. Okay, then the next one. If 2x is equal to 9, well, okay, let me just write out my answer, I guess, for this one. X is equal to 0. Now the next one. B, if 2x is equal to 9, what is the value of 2 to the 6x minus 23? Well, 6x is just 3 times 2x, which they said is 9, so 3 times 9 is 27. So here we have 2 to the 27 minus 23. 27 minus 23 is just 4. So we have 2 to the 4, which is just 16. Okay. And now, when they have this symbol, it means write out your solution. So to determine the coordinates of the point of intersection of the lines with equation y equals 3x plus 7 and y equals 7x plus 3. Okay, well, this one as well, I know that if x were just equal to 1, it would be 3 plus 7 and 7 plus 3, both of which are equal to 10. So I already know my coordinate. I know they will be the same when x is equal to 1. Well, okay, I guess this whole question is about writing it out. But, so if we have 3x plus 7 is equal to 7x plus 3, if I want to do it algebraically, I subtract 7x from both sides. I have minus 4x plus 7 is equal to 3. Subtract 7 from both sides. Minus 4x equals minus 4. X equals 1. And y is just f of 1. So 3 times 1 is 3, plus 7 is 10. So my coordinate is 1, 10. That is our answer. Okay, on to question 2. There is one positive integer for which 3 is less than the square root of k squared plus 4, which is less than 4. What is the positive integer k? Okay, so basically, this means that, okay, so 9 is less than k squared plus 4, and k squared plus 4 is less than 16. Okay, so k squared, if I subtract 4 from both sides of here, I get that 5 is less than k squared. Okay, so I know that k has to be bigger, which tells me that k is bigger than 2, right? And then k squared plus 4 is less than 16. Subtract 4 from both sides. K squared is less than 12. So I know that k squared has to be less than 4. So sorry, k has to be less than 4 because 4 squared would be 16. So what's the positive integer between 2 and 4? We get 3. So k is equal to 3. That'll be my answer for that one. Okay. B, what is the sum of the 20 smallest odd positive integers? Okay, we're gonna do that one here. Okay. So what is the sum of the 20 smallest positive integers? Right off the bat, I'm thinking if you wanted to just find the sum of any list of integers, period, say example from 1 to 100, how would I find that? Because I'm just thinking on the root of sums. Well, you would notice that the numbers 1 and 100, when you add them up, it gives you 101. Likewise, take one step up and one step down. So you added one and you subtracted one. It means that the sum should be the same, right? That will also be 101. So how many pairs of, how many doubles can you make with the extremities of your list, right? 1 and 100, 2 and 99, 3 and 98. You can only make 50 of them, right? 50 times 2 is 100 integers. So there will be 50 pairs, and each one of them will have a sum of 101. So the total sum would be 50 times 101, which is 5,050. So the formula that kind of equates this, I guess, is n times n plus 1 on 2, right? N on 2 is how many doubles you can make, and n plus 1, this would be like n is 100, and this is the sum, right? 100 plus 1. But we're talking about over odd numbers, right? But that should be the same. So if I had like 1, 3, 5, 7, 9, and 11, right? Each extremity would also add up to the same sum of 12. So I know that this rule will hold for the precise, like here I have 1, 2, 3, 4, 5, 6, and I have 3 doubles. Okay, so yeah. If my list has an even amount of elements, this will work, I think, hopefully. But now let's actually get to the problem. The first 20 odd numbers. So if I just take the first 20 numbers, period, I know that half of them should be odd, right? Half are even, half are odd. So if I want 20 odds, I need to look at 40 numbers, and half of them will be odd. So if I'm looking, so all numbers from 1 to 40, half are odd. My list will go from 1 to 39, right? Which means, and I know that in my list, I have 20 elements, right? An even number of elements, so this should work. So it will be, so my extremities will add up to 40, right? 1 plus 39 equals 40. And like 3 plus 37 is also 40. So my sum will be, so how many elements do I have? I have 20, and then all of them add up to 40, so that's 40, and the number of doubles it will be 20 divided by 2. So this is just 10 times 40, so my sum will be 400. That's the sum of the first 20 odd numbers. Okay. And now let's do part C. In the diagram, BDF is equilateral, and FAB is equal to BCD is equal to DEF is equal to 90. Okay, so those are just angles, and it's saying that this angle is equal to this angle is equal to this angle. And this, of course, is our equilateral triangle where all the sides have the same length. Also, BC is 8, AB is 16, AF is 13, DE is 5. And they're asking us to find the perimeter of the hexagon. Okay, honestly, I think that's okay. We only have 2 side lengths to find, right? We have this one, and then we can just add them up with all of these and find the perimeter from there. Okay. So what's really going to help us in this is that this is an equilateral triangle. So by extension of knowing these 2 side lengths, I know this side length by the Pythagorean theorem, right? So if I have a triangle like this is A, this is B, and this is C. The Pythagorean theorem tells us that A squared plus B squared is equal to C squared. So C is just the square root of A squared plus B squared. And if I take this triangle here with sides 13 and 16, I get that C is equal to the square root of 13 squared plus 16 squared, which 13 squared is 169, and 16 squared is 256, I believe. So if I just try and calculate that for 16 squared, that's 12 times 20, 240 plus 16, 256. Okay, adding these up, I guess we're just gonna go mental math. So 200 plus 100, 300, 60 plus 50, 110, so 410, and then 9 plus 6 is 15, so 410 plus 15 is 425. So C is the square root of 425. Okay, I also know that this C, it's also this, and it's also this. Okay, so why did I find this if I already knew both of these side lengths? Well, because C is also in this triangle. And if I know 2 sides of a triangle, I can find out the third, which is CD, and I need to find that. So that's also what I'm going to be doing on this triangle. Okay, so I know if I'm trying to find CD, so let's just call that side A, right? A is equal to the square root of the hypotenuse squared. So square root of 425 squared. And what's the other side length? 8 plus 8 squared. Ooh, sorry for the writing, guys. That's an 8. Is equal to the square root. So the square of a square root, they just undo each other and you get whatever number was inside your square root. So that's just 425. And 8 squared is just 64. So this is the square root of 489. Now let's look that up. Square root of 489. Oh, did I maybe add this up wrong? Because that's not really a nice value. Oh, of course. It's not adding, sorry. Hypotenuse minus your side, right? Not plus. Okay, I mean, minus 64. And minus 64, right? So that's not 489. And you guys understand why it's minus, not plus. So if I look at this triangle, this is my Pythagorean theorem. So if I'm trying to find a squared, I subtract b squared from both sides, and I take the square root of a square to just isolate a. it will be the square root of c squared minus b squared, not plus. So that's my bad deal. Okay. And now this, yeah, maybe not mental math. 425 minus 64. 425. I think we're allowed calculators for these tests. That's 361. And okay, is 19. Okay, nice. So I think CD we were talking about is 19. And so now I've got that one down. I just need to find FE, and then we've solved it. So FE, I know C and I know 5, so I can find FE. So for FE, let's call it A as well. A is equal to the square root of C squared minus B squared, right? So that's running out of space a bit. Square root of square root of 425 squared minus, what is its side length? Minus 25, okay. So that, remember, the square of a square root cancels, so we have square root of 425 minus 25, square root of 400 is equal to 20. So FE is equal to 20. And so the perimeter of this hexagon is just the sum of all the sides. So this was 19 and this is 20. Okay, so now adding these all up. So, 19 plus 5, that's just 24, plus 20, that's 44, plus 13, that's 57, plus 8, that is 65, plus 10, that's 75, plus 6, that's 81. So, write this out here. Perimeter is 81. Nice. Okay, moving on to question 3. So I have, suppose that P plus Q plus R is equal to 18 and P plus Q is equal to 5 and Q plus R is equal to 9. What is the value of Q? Okay, so for this one, it's fairly straightforward. It's a substitution, or not an elimination problem. Basically, if I add up this, if I subtract this and this, it'll be the same as 18 minus 9, but when I subtract P plus Q plus R, if I say P plus Q plus R minus Q plus R, right? That's the same thing as P plus Q plus R minus Q minus R. All of these cancel. I just get P, and this is equal to 18 minus 9, right? So it's equal to 9. So P is equal to 9. So if P equals 9, that means 9 plus Q is equal to 5. So Q is minus 4 by extension. Okay, let's move on to B. The line with the equation 6x plus y equals 24 has its x-intercept at point P and its y-intercept at point Q. What is an equation of the parabola whose y-intercept is at Q and whose only x-intercept is at P? Okay, let's do this problem down here. So I'll draw this out. So I already know that this parabola has a single root. That's what it means to only cross the x-intercept at one point. It also means, well, never mind, I'll explain that later. Oh wow, that doesn't even cross it. Let me try and draw this nicely. Honestly, that's probably as nice as it will get for me. So, they said y-intercept is q, and this is p, and there is a line who shares the same x and y intercept. And the good thing is they give us the equation of this line, right? So if 6x plus y equals 24, that means that y, subtracting 6x from both sides, is equal to minus 6x plus 24. Okay, so now what is q? What is this y's y-intercept? So to find that, you just substitute x with 0, because all along the y-intercept, x is equal to 0. So that means that y-intercept, or I'll just write q, since he actually gave us a variable for this. So q is equal to 24. And for the x-intercept, where the height is 0, so y is 0, if I say 0 is equal to minus 6x plus 24, I'll subtract 24 from both sides, right? So minus 24 is equal to minus 6x. And divide both sides by minus 6, I get 4 is equal to x. So p is equal to 4. Okay, so what does this tell me about my parabola, who I'm trying to find the equation for? Well, because the parabola only crosses the x-intercept at one point, I know that that has to be its vertex, right? So vertex form of a parabola is y equals a x minus h squared plus k, where h and k are the coordinates of the vertex. The coordinates of this vertex is 4, 0. So I'll just sub that in. Y is equal to a x minus 4 squared, and k is just 0. But now what do I do with my a? Well, I know the y-intercept. It was 24. So when x is 0, y is equal to 24. So 24 is equal to a times the minus 4 squared, right? I just replaced x with 0. So 24 is equal to 16a. 16a, dividing both sides by 16. 24 on 16 is equal to a. Divide the numerator and denominator by 8, and I get a is equal to 3 on 2. And now I have the last piece to write the equation, right? So the equation of my parabola is just 3 on 2 times x minus 4 squared. Okay. Yeah, now of course, one last thing to say is that this isn't the only equation that's right. That's why they said an equation, because my parabola could also be going this way, in which a would be negative. Although, no, sorry. No, never mind, not possible. That's actually not possible, because in that case, the y-intercept would be negative. So no, it's not possible. Okay. No, I had one more question left, right? The next question is, suppose that 1 over, I feel like, can I take a screenshot of this and like add it? No, I'm already doing a screenshot, so I can't do that. Okay, anyways. Suppose that 1 over 2w is equal to 1 over 3y is equal to 1 over 4z. And 1 over 2w plus 1 over 3y plus 1 over 4z is equal to 1 over 24. Determine the value of w plus y plus z. Okay. Let's use another color. So that means that this sum, all of these terms are the same. So I could just say, if I just replace if all of these variables are the same, I can just replace them with each other. So this is just 3 times 3 3, oh, that didn't change color. This is just 3 times 1 over 3y. And that's equal to 1 over 24. So these 3's cancel and I get 1 over y is equal to 1 over 24, which tells me that y is equal to 24. Alright, so one variable done. Next, I have 3 times 1 over 2w. So 3 times 1 over 2w is equal to 24. Is equal to 1 over 24. So if I divide both sides by 3, right, I'll get, well, why don't I just, this is 3 on 2. So I'll just divide both sides by 3 on 2. That's the same as multiplying this side by 2 over 3. So 1 over w is equal to 2 on 3 times 1 over 24. So 1 over w is equal to 2 on top of 72, right? Actually, so 1 over w is equal to 1 on 36. Tells me that w is equal to 36. All right, one more variable. And that is z? Was that a variable? I don't remember. Anyways, okay. I'm just gonna guess and go out that's gonna be 100, but who knows? Yeah, we need to find z. So I have 3 over 4z is equal to 1 on 24. Right? I just added 4z 3 times. Okay. Now once again, I'll divide both sides by 3 and 4, which is the same as multiplying this side by 4 over 3. So 1 over z equals 4 on 3 times 1 on 24. And this time I'm going to simplify before going in. That's a 4, guys, not a 9. Okay. That's a z, not a 2. So 4 on 24 is just 1 on 6. So 1 on 6 times 1 on 3, that's just 1 on 18. So 1 on z equals 1 on 18. Z is equal to 18. Okay, so I have 24 plus 18 plus 36. That's not going to be 100, guys. 78, I believe. Yeah, so the sum is 78. Wow, I had a lot of space. I don't know why I was squishing like that, but sum is 78, if I haven't made any mistakes. Okay, question 4. Guys, we only have one left after this. All right. Honestly, I don't feel like they've gotten too hard yet. Just a little bit worrying, but okay. Maybe this will be the one, honestly. Probably. 4. Terry's bicycle has a larger front wheel with radius 15 and a smaller rear wheel with radius 9. Terry ties a ribbon to the top of each wheel and then starts to ride forward. Terry travels d centimeters forward and stops. Both ribbons are again at the top of the wheel. What is the integer closest to the smallest possible value of d, with d is bigger than 0? That is not comforting, but okay. So at what distance will both of these have done a full turn? Okay. So when will the ribbon have done the full perimeter. So what's the perimeter? I say we start with just defining the perimeter. So we'll call this P1 and this P2. So P1 is equal to 2 pi r. So r is 15, so it's equal to 30 pi. P2 is equal to, again, 2 pi r. R is 9, so it's 18 pi. So, I guess they want the smallest multiple between common multiple between this and this. Yeah. So let's just think 3 times 18, that's 54. Maybe I should just decompose them. Maybe this is 3 times 3 times 6, and then 3 times 5 times 2. Okay. 18 and 10. What do you have to multiply? I mean, there's 180, but there's 90. So 80 times 5 will give you 90. Or 18 times 5 will give you 90. Okay, sorry. I just need to think for a bit. 3 times 3 times 6. Do you ever feel like you think about a problem too much and you start to lose grasp of the problem? Like, I feel like that's happening. Okay, anyways. How many? Yeah. I mean, I feel like obviously 90. Sorry, brain cells, wow. But if 90 is the most common multiple, what are they asking for? Terry travels d centimeters forward and stops. I think it's I'm not sure if I understand. I mean, okay. I'm gonna go out and say 90 pi. But what is the integer closest? Okay, integer. But that's not small at all, so it's a bit worrying. But whatever. Well, we'll just 90 times pi. By the way, guys, this is just me going along. So if you're like, well, that obviously doesn't make sense. I guess it obviously doesn't make sense. But I'm going to go over and look at the correction as a group at the end. So I don't have you guys leaving with any wrong conceptions. 283. But I thought it would be, honest to show the true process. And also, this is the journey to thinking like a mathematician. So eventually we'll get there, guys. Okay. In the diagram, ABCD is a rectangle with AB equals 24 and AD is equal to 18. Okay, so that by extension means the same for these sides. Also, E is on BC with EC equals 6. Okay, so that tells us BE as well. If segments DE and AC intersect at F, determine the length of CF. Okay. Okay, so what they want us to find is this. Let's just keep that in mind. So the length, right, will be the height. Well, okay, let's go step by step. Okay, so I know that this angle and this angle are these two are the same, and that this and this are the same. Which also means that these are the same. So these should be similar triangles. So just like scaled down versions of each other, I think. I don't actually know how that's gonna help me though, but okay. Well, I know BE is 12. Oh. Okay. If I know this is 6 versus this is 18, this triangle is scaled down by 3. It's the same as ADF on 3. It's 3 times smaller, all the sides. But now my question is just, how am I gonna find this side length, I think, is the one I'm trying to find. Okay, how do I do that? This is 6, this is 90 degrees. Oh, I mean, I could technically find this entire side length. I think I might try doing that actually, because it would be whatever C is plus, no, that's not what I want to do. I want to do it the other way. Wait. No, sorry, that was right. If I do, if I find this, right, I know this is 24. So if I find, and I know this is 6, so I can find the entire hypotenuse, and then I know that it will be C plus, oh, sorry, I just did the same mental reload twice. Okay, that was not what I want to do, and the reason is because I want to find this, so I'll use this triangle. So 24 and 12, I can find this hypotenuse and know that, so I don't know this side. Oh, this is a bit frustrating. Let's go back to the previous setup. Oh, wow. It's taking off a lot. Okay. What the heck? Okay. If I do this triangle, it will be this side plus whatever other side, x. Why am I hesitant towards doing this? 20, so if I do this one, it would be, I find the hypotenuse, it would be minus whatever this. I guess I should just try something, right? Because I'm not really doing anything besides plugging myself out right now. It's also the intersection between these two hypotenuses. Maybe if I just treated them as like lines with this being 0. So like this line, and like let's just call this the x-intercept, the origin point. So this line would have a y-intercept of 0. No. Let's call maybe this the origin. Never mind. So y equals mx plus b. I know its slope is, so rise over run, so 6 over 24, so 1 over 4. 1 over 4x, and let's just, yeah, this will be our origin. So b is 0 versus y2. Its slope is rise over run, so minus 18 over 24, so minus 3 over 4. Minus 3 over 4. X, and it touches the y-intercept at 18, plus 18. So if I find, I don't know, where these two touch. So I'll set them equal to each other. So 1 over 4x is equal to minus 3 over 4x plus 18. Adding 3 over 4 and 1 over 4, that's 4 over 4, so it's just 1. Oh, why is my x down there? Sorry guys. X. So x is equal to 18. Well, that was straightforward. Okay. X is equal to 18, and then, so, f of 18 is 9 over 2. So this over here is 9 over 2. And this is 18. So okay. Ooh. 9 over 2 and what I have? 18. Now I can just do the distance, like finding the hypotenuse of this triangle, right? So that's the square root of this. Will take this point and this point. So it'll be subtract their y's. So it's 9 over 2. 9 over 2 squared. Wait, sorry guys. I'm trying to just figure this out. 9 over 2 minus 0. Right? That's the vertical total distance. Plus, now find the x distance. This was 18 and this is 24, so there's a difference of 6, so I'll just write it out. So 18 minus 24. So that's 81 on 4 plus 18 minus 24 minus 6 squared, so plus 36. Plus 36. Square root of answer is 7.5. Okay, so that's our guess. I mean, length of, what was it? FC? Length of FC. .5. Okay. Cool. I mean, happy to try, right? Okay. Last question, guys. So Alice has a lock whose combination consists of 3 integers, a, b, c, which need to be entered in that order. Okay. The 3 integers satisfy the following. Each of a, b, and c is between 1 and 40, inclusive. A, b, and c are all different. B is less than a. So b is less than a, and b is also less than c. And one of the integers is 20, and another of the integers is 30. Okay. So I know that b is the smallest. Ooh, how many possible integers satisfy these conditions? Oh my gosh. What a problem. Between 1 and 40. Okay. I know that b is not equal to 30. I know that they gave me 2 of the integers, by the way. I know that either a is equal to 20, in which case c is equal to 30, and B can be anything from 1 to 19, or A equals 30, B is equal to 20, sorry, A is equal to 30. Let me redo this. Oh wow, there's a lot. A is equal to 30, C is equal to 20, and B, again, is equal to anything from 1 to 19, or A or C could be bigger than 30, right? Because it's 1 to 40. So if 30 is not the maximum, then B could be equal to 20, right? So B equals 20. A equals 30, and C is, they didn't specify, no, they're all different, okay, so they can't be equal to one another, and so C is anywhere from 31 to 40. Likewise, B could be equal to 20. C would be equal to 30. And A would be, gosh, there's still so many more. And A could be anywhere from 31 to 40. Honestly, just looking at this problem makes me scared. But what if 30 is the maximum and B is still equal to 20? Then you could have any number between the two. So B is equal to 20, A is equal to 30, maximum, and C could be anywhere from 21 to 29. I wonder if there's like a faster way of doing this. B is equal to 20, A is equal to, C is equal to 30, and A is anywhere from, wait, why am I? This is literally the same thing. Why am I saying it twice? It's not like a list of numbers. It's just what are the numbers, period. So I don't need to have all these doubles that I have. Oh. Anyways. Okay, repetitive, but I'll just knock that out. Yeah. Yeah, okay. So really just, there's 3 that I have. So either B is anywhere from 1 to 19 and 2 of the other digits are higher and are 20 or 30. Either B is equal to 20, A is equal to 30, and C is somewhere between 20 and 30, or B is equal to 20, A is equal to 30, and C is something bigger than that. I think those are my possibilities. And how many possible combinations satisfy this? Honestly, I'm tired of looking up on Google Calculator each time, so I'm just going to use the calculator that I have. So for this one, we have 1 to 19, so 19 to... Hey guys, sorry, my phone died. But anyways, where was I? Well, I had just realized I had written, sorry, I just realized I'm not actually screen sharing yet. Let me sync this up. Okay, anyways, yeah, so I just realized that I had written, all of the possibilities twice for no reason. But if I want to find how many different combinations satisfy these, I know that there's 19. I was also having some trouble counting, but there's 19 cases. If A is equal to 20 and C is equal to 30, there's 9 cases. If B is equal to 20 and A is equal to 30, or either the other two is equal to 30, and there's, oh, sorry. It does matter. It does matter if one is equal to, if they're equal to different ones. I don't know why I crossed these out, because it's a lock combination. So if it's A, B, C, yeah, all of these count. So there's 19 cases where either A is equal to 20 or C is equal to 20 and vice versa. So we have 19 times 2, that's 38. And then if B is equal to 20, then either A could be equal to 30 or C could be equal to 30, and then there would be 9 cases for the other digit, which would have to be between 31 and 40. So 9 times 2 is 18. And then the last one was if 30 is the highest digit and B is the lowest, 20. So your third digit has to be between 21 and 29 inclusively. So sorry, I just realized that's not 18, that's 10. Wait, hold up. So that's 20 here. So this is 10 and that's 10. So that's 20, and likewise this is 20. So I have 40 plus 38, so that's 78, I want to say. I'm not really confident about this, guys, but it's about the process of learning. I honestly feel like it's my counting that's sabotaging me right now. So let's just do this. 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Yeah, that's 10. So this should also be not 10. Hello. This is not 78. Let me undo the things I wrote. No. So yeah, this is gonna be 8. Sorry, this is gonna be 9. Whew. So 2 times 9, so 18. Oh my goodness, that's a journey, guys. 46, 56, 76. Okay, that's what I want to guess. Who knows? Who knows? Who knows? Okay. Angles, trigonometry. So much nicer, hopefully. For some angles theta, the 3 numbers 2 minus 2 cos theta, 1 plus sine theta, and 2 plus 2 cos theta form a geometric sequence in that order. Determine all possible exact values of cos theta.
Only through me can you achieve
You happy?
greater than any
You
generation.
happy, puppy?
Learn to know the dark side of the Force, and you will be able to save your wife.
Sorry guys, so I was booked for a few minutes there. Anyways, so for some angles, theta, the three numbers, these ones. Oh my goodness, I forgot to restart my recording. Okay, now, let me restart. Yeah, so for some angles, these will form a geometric sequence, which they say is where each, like this term is k times the first one, and this term is k times the first one, right? Okay, so I need to find k. Well, that's what I want to do, I guess, but maybe I don't need to. But anyways, let's get to this. So I have a feeling that this one, I don't actually know. Okay, sorry, I'm kind of just rambling. So k times 2 minus 2 cos theta is equal to 1 plus sine theta. Okay. Yeah, that's what it says. Okay. And then, so I know that k is just equal to 1 plus sine theta divided by 2 1 minus cos theta. And then the second equation I have for k is this in this term, so I know that k times 1 plus sine theta is equal to my final term, 2 plus 2 cos theta. 2, 1 plus cos theta. Wow. This is glitching. So k is also equal to 2 times 1 plus cos theta divided by 1 plus sine of theta, which I know from before is equal to 1 plus sine theta divided by 2 times 1 minus cos theta. I need to find for which theta is this true. So I feel like we're just gonna simplify a bit here. These terms are very similar. Okay, so if I multiply 2 times 1 minus cos theta on both sides, I'll get 4 1 plus cos theta times 1 minus cos theta, and we know this is an identity, right? Now multiplying both sides by 1 plus sine theta is equal to, ooh, these parentheses look terrible, guys. All these straight lines you see are meant to be parentheses, by the way. 1 plus sine theta squared. Okay. So, 4 times 1 minus, oh, this is so glitchy, I actually can't do this. Anyways, 4 times 1 minus cos squared theta. Come on, come on. Is equal to 1 plus sine theta. Ooh, okay. This is just going to boil down to a quadratic equation because 1 minus cos squared theta is just sine squared theta. So 4 sine squared theta, or why am I saying I have x and theta? Look at this disorganization. 4 sine squared theta is equal to, now let's expand this square, 1 plus 2 sine theta plus sine squared of theta. Oh my god, this looks terrible. And again with the x's and thetas. Okay. Anyways, x is equal to theta. Now, subtracting 4 sine squared from both sides, I get minus 3 sine squared of theta plus, I really hope I don't need to go to the quadratic equation for this, 2 sine x plus 1, and I don't, is equal to 0. Alright, so I personally like to just take the negative out. I don't know, I feel a bit traumatized with the negative. So we'll say 3 sine squared theta. What I'm doing is I'm just gonna like divide or multiply all the terms by. Guys, my phone is against this video because it just told me once again for like the 5th time that I have no more storage. So let's make this fast. Minus 2 sine theta. Ooh. Wow, I feel like I'm moving like really slow though. Like, why is this actually like not working? The computer is also against me. Technology is against me. Okay, so this is just factorizing. So what has a product of minus 3 and a sum of minus 2? That's minus 3 plus 1. So I have minus 3, 1 divided by 3, right? The leading coefficient. That's how you factorize, or that's how I was taught to factorize. So this, minus 3 on 3. Yeah. So that's just minus 1 on 1 and 1 on 3. So the denominator becomes the coefficient for x. So it boils down to x minus 1 times 3x plus 1 is equal to 0. So the x1 or theta 1 is equal to 1 x2. Sorry, remember these x's are sine of x. I just randomly replaced it. Oh, guys. So when is sine of x equal to 1? It's either when theta is, well, it's just when theta is 90 degrees, right? Or pi on 2. And then, sorry, what is this? That's supposed to be a 3. So if 1 is sine equal to minus 1 on 3, okay. I actually don't know if this, I'm assuming this isn't radians, but I actually don't know. Or, anyways. I'm gonna do sine minus 1 of 3. Hey guys, sorry, my phone died once again. But anyways, I was finding what theta is if I have sine of x equals minus 1 on 3. And in a second, I'll write what that was equal to. Again, I'm doing it in degrees. but it gave me minus 19.47 degrees. And then I just translated that into a positive value, right, by adding 360 to it. So that will give me 340.53 degrees. Or just 5. Okay. And so that's, of course, if sine is equal to a negative value, there's two different angles that it can be, right? Because there's two different quadrants that are negative, that have negative height. So my other angle is just 180 plus 19.47, which gave me 199.47 degrees. So those are my two angle values, except I thought that the question was asking angle values. They want, what will cos of that angle be? So I circled those as my answers, but really that's not what the correction wanted. So I'm going to show you an image of what the correction actually wanted. So I gave mine in degrees, which is not exact values. Maybe if I had read the instructions for the test, I would see that they want exact values. I don't know. But all I would have to do is, well, I already knew that sine of theta is equal to minus 1 on 3. So I also know that cos squared of theta is 1 minus sine squared of theta. So sine of theta is minus 1 on 3, so sine squared is just minus 1 on 3 squared. So cos squared is 1 minus that. So that's 8 over 9. So if I just want to find cos of theta, it's the positive and negative square root of that, as well as 0 from my first answer, right? I don't know if I would have made this leap, but, you know, just reading this, maybe I'll find out next time. Anyways, I'll do problems 6 to 10 in my next video, so thank you for watching. I hope it helped.